or to do a complex kind of analysis. All right. So I'm Asari, and I'll be leading you through the training for today and that of next week, God willing. Okay, so please, this class is more of interactive. You ask more questions and then you bring your input so that the class will be quite interesting. So whatever question that you have, you can bring it on board either after the session or in between. You can also bring it so that we all look at it. Okay. So we are beginning with the session. In fact, we are putting all the slides together so that at the end we would make them available to you. We are not going to focus much on the slide because it should be application, but we will need to do some basic introduction to certain concepts when it comes to data analysis, a bit of research, an overview of the software. Then we can zoom into the main application. Okay, so I'm going to share my screen. I'm sharing my screen. Okay. Okay, so to begin with, we are going to start with, please, can you see my screen?
Yes.
Okay, all right. So we are going to begin with basic concepts when it comes to statistics. In fact, I must say that when we talk about statistics, or when someone says that I know how to use SPSS, the only question that sometimes I ask is, do you understand the concept of the software application? The software is basically a kind of statistics. It was built based on statistical principles. So if you can use the software effectively, then you should have some basic concepts when it comes to statistics. Okay, so what is statistics? I think it will be appropriate if we share ideas before we move on. Do we have someone with the knowledge of statistics or who can share or tell us something about statistics? Just something small, what you know about when you talk about statistics. Please, anyone can start.
Okay, so I think statistics has to do with the gathering of data and trying to describe or summarize them to be able to get an insight into that data.
Okay, that is great. That is great. So yes, so what is statistics? As rather said, it is concerned with you trying to have some kind of data, and then you describe the data, you summarize this, and then you make a kind of decision from the data. So basically, it's concerned about someone gathering or you gathering data set. You would summarize it, and then you draw conclusion or inferences from the data, which means that there is something like gathering, which the gathering, there are a whole lot of things that goes into the gathering. And then you also have the summary, one way or the other, maybe how you can put them tableau or table form or whatever it is. And then you make some kind of inferences from it, whether you are using a descriptive tool or an advanced statistical tool to make your decision from the data set. So that is all about statistics. And there are so many things that goes into it, which I don't think we would go into the mathematics aspect of it, but at least some basic things that you need to know about it will be given you. Okay, so sometimes people look at it from the mathematical point of view. Yes, it is, but statistics is more than a computations. It goes beyond those adding, subtracting, and dividing. There are a whole lot of things that you can do, not only 2 plus 2 or 4 plus 4, but you can do so many things. Okay, when it comes to this kind of artificial intelligence that of late it has become the order of the day, there is statistics what behind. So it is not just about our normal core mathematics that we do, but it goes beyond that. But I must say that without those concepts, it will be difficult for you to also appreciate it. If you don't get the concept right from the beginning, it will be difficult for you to get into the mainstream when it comes to statistics. Okay, so that is about what it is, and then it also helps you to be able to answer some basic questions around you or around us of able to make a better decision from how things came to be. And it is something that we must all get it done. All right. Okay. Now, there are other concepts like a population, which you can't do away with it anytime you talk about statistics. So what is population that we see? So we are saying that population is all about what is around you. The totality of it is what is called, in a simple term, what is called what? Population. Okay, what is called a population? So if you take the student population, or if you take student Hello.
Yeah, I think we lost you.
Oh, okay. 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 All right. Please,
Can you
hear me now?
again?
All right. Let me do
Yes.
that. Okay. 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 Oh. Okay. So we are saying that population refers to the totality of, it could be an individual, it could be trees, it could be animals or whatever. So if you put all the individuals together, you are getting what is called a population within a confined area. So Ghana, for instance, if you put everybody on board, children, adults, let's say men, women together, that is the population of what? The country. Now, because sometimes it is difficult for you to deal with population, you try as much as possible to have a section of the population for your study, which we call it a sample. Okay, so because you will not be able to do the entire population, you try as much as you can to be able to get a sample of the population or a part of the population for you to use it for your kind of study or whatever that you are doing. So a part of the population is what is called sample. And it is appropriate if you don't have the means to be able to embark on a complex study that involves a lot of what people. And I believe all of us, one way or the other, we are doing research. So you realize that as part of the research, you are unable to gather all the information that you need from the population. Maybe you are looking at the human resource people in or employees that are in HR or that are practicing HR. You realize that you can't get everyone on board. If you're able to get everyone on board, that becomes what? Your population. But because you will not be able to get everyone on board, you need to take portion. So you focus on MTN Ghana, Vodafone, or whatever, any company that you think you can get some numbers to form part of the study, you fall on them. So that becomes your sample. As I said, it is not appropriate. It is not appropriate to embark on, it is not even feasible, let me put it like that, to embark on total enumeration for a study. Okay, but if you have the means to do that, that is fine. If you have the time, you have the resource to interact with every student on campus, that is fine. That is perfect. But if you don't have that means, then you need to fall on few of such, and then you use them for your study. Okay, so there's another concept that we call a parameter. A parameter. So a parameter refers to some basic characteristics of the population. So someone will say that, okay, I was able to gather the entire or interact with the entire population, and I computed the mean or the standard deviation. That becomes the population statistic, or let's say the population parameters. Okay, but if you're also unable to gather the population, information about the population, and you focus on the sample, it is called static, okay, or statistic. Here we don't add the S to it. The moment you add the S, it becomes statistics, which becomes like a course on its own. So statistic become the information that you obtain from the sample. So the sample mean, sometimes you hear sample mean sample median, sample standard deviation, and so on. It means that it is from the sample. Now, we have what is called unbiased estimator. That is, whatever information that you obtain from the sample, it must represent the population. So if you compute the mean from the population, it must one way or the other represent that of what the sample. Then we can talk about what unbiasedness here. So the moment it's the same as that, then there is no what bias in terms of the estimate that you have. So it will be appropriate for you to sample very well so that your sample can represent your population. And I believe once we are all, let's say, in school or maybe conducting research, some of these basic things will come. And when it comes, we need to be able to address it. One way, someone will ask you, how did you get your sample? You should be able to let a person know the size of the population and then how you were able to get the sample to form part of the study. It is very, very important to take note of some of these things. In fact, I am not teaching pure statistics here, but some of these concepts will help you when you are maybe, defending your research work or maybe presenting what you have to your professors or to your lecturers, or maybe in the job, or maybe where you find yourself, management will appreciate some of these basic things that you do for them to take a decision on it. Okay. Now, there is another concept under the statistics. We call it descriptive statistics. Now, the descriptive statistics is simply put, it looks at, let's say, an object and then it describes it as it is. So basically, they are called descriptive. So they just look at a group of people around and says, oh, well, looking at the way you people are, this is what I can use to describe you. You are nice people. That is it. It just sees you and describes you in a simple terms. Okay. And anytime you hear of statistical tests, please take note that it is not about the descriptive that we are talking about. The descriptive are just there to complement whatever thing that you are doing. They are there to complement it. But that is not the main kind of test, especially if you want to make an informed decision. Anyone who wants to make an informed decision will not rely on the descriptive because it will only tell you the minimum, the maximum, the mean, and so on. But it is unable to go deeper into the data to tell you how one variable varies from the other. So let's take note of that. And some of the descriptive statistics, we have the mean, the standard deviation, the minimum, maximum, skewness, those basic things. They are there to, help you describe your data in a more formal way. They are good. I'm not saying they are not good. You take a typical social science student, you realize that the only thing that you see in it is descriptive. It's understandable because they might not require technical statistic tools. Yes, but at a point, they will also ask you to do inferences, which will be the next one. So when it comes to inferential tests, those are the tests that we say that they help you to be able to go into the data and draw decision based on the kind of data that you have. Okay, so for instance, if I have a data set and I want to know how that data differs from, let's say, a standard data or a predetermined data, okay, I can't use just the descriptive to say that this is how my data deviate from the minimum wage. Okay, so if the minimum wage is in quote 20 Ghana cedis, the minimum wage is 20 Ghana cedis. And I want to find out how Ghanaians, or let's say employees in Ghana, our salaries, let's say, deviate from the standard wage. I can't just use the descriptive to just do that. I need to go around, gather data from employees, and then test the data that I have gathered against the predetermined value that they've given to us, that the minimum wage is, let's say, 20 Ghana cedis. So in that case, we have moved from the descriptive to more inferential analysis, okay, which we will look at it once we are done with the, the basic concept when it comes to the statistics. Okay, so that is about the inferential and then that of the descriptive statistics. Okay, the material is very, very rich, and I believe once you get it, you can use it for your own things. Okay, now this is the concept, putting the population, the sample together in this diagram form. Now, in statistics or in research, we deal with a kind of a data set. So someone will be working with a data set which is more numeric, or it could be a string, it could be a ratio or so, or whatever. But basically, we have four types of data set that we have. We have four data set that mostly researchers will work on. So the first one could be a nominal data. We have a nominal data set. The nominal data set is, it could be just a gender. Okay, gender. So your variable gender is a nominal because it's just group that you have created, no special effect or let's say impact. If you are a male or a female, that doesn't qualify you to be more powerful than your colleague, female, in the job or at the workplace. So you realize that once you are able to put it in category male, female, there is no special effect on it. So it becomes nominal. That is a typical example that maybe you can have. Or let's say eye color. You see the eye color of a white man and then that of a black man. Does it mean that if your eye color, maybe a white man's, let's say eye, does it make that person so superior than us, the black? No. Okay, so that is about the nominal. Anyone who is working with a nominal data looks at it. You don't put any special effect on whether you are a male, so you deserve this, or you are a female, you deserve that. Once the category has been created, we are all equal. Okay, so that is that. Now we have the ordinal. The ordinal comes in the moment you try to put special impact on a specific, let's say, a level. Okay, once you begin to put impact on it, that's because you are a male, you are special than the females, then it becomes ordinal, right? So ordinal all the time has some kind of impact. There is a kind of impact that you put on. It is very, very important to take note of that. So the military ranks, for instance, sergeants and so on, they are all ranks because the moment you see your superior, you need to be able to salute the person. So that is that. Okay. All right. Please, any question? Or am I going too fast?
It's okay.
Okay. All right. Okay, so I think I can move on. I said the slides will be given to you. Okay. Now we have what is called the interval scale. Now the interval scale is more continuous. Interval scale or interval is more continuous, or it's a form of number. Okay, so you are dealing with what? Numbers. Okay, so let me combine the interval and then the last one, which is called ratio. Okay, so there is another one called what? Ratio. So the ratio, for instance, you have a data set like temperature of the AC. Okay, so you are working with data relating to, let's say, AC. You go around and be taking temperature of people. You can classify it under what? Ratio, right? So ratio and then interval are put together to form what is called a continuous what? Variable. Okay, they are called continuous what? Variable. So ratio, interval, or let's say ratio and then interval together is called a scale. So in SPSS that we'll be using, you are not going to see interval scale and then ratio scale there. What you are going to see is what is called what? A scale. So please take notes, right? Take note, and once we get there, you don't get what? Confused, right? That we have interval and then that of ratio now put together called what? A scale. It is very, very important to take note of that. Okay, so that is with the basic concept when it comes to the measurement. So I have mentioned 4. That is the nominal, ordinal, interval, and then that of what? Ratio. We have different data types like the district and so on. But the district is just basically you have some kind of yes or no kind of comes in. The district more of a kind of a qualitative data set whereby you can put some kind of what? Groups within. It all forms part of the district, and then that of the continuous, as I said, it is more of the numeric in nature. Okay, so please take note of that. I will share the slides with you. Once you get it, you'll be able to get a better understanding to it. My team, they've been able to put up, add more information to it that can help you to study on your own. All right, please, any question with respect to the basic concepts to statistics? Any question from the beginning to where we are now? Any question?
Hello.
Hello.
Please, can you go over with the difference between statistics and statistic? The one with S and
okay.
the one.
Okay. All right. So the statistics is like the course. So as we are saying, statistics is all about you gathering your data, analyzing it, and then you make decision. And then the one without the S is what you estimate from your sample. So if you are, let's take student population, for instance. So you are dealing with, let's say, student in a particular school. Putting everyone together or putting all the students together is called the population. Now, because maybe your resource might not help you to be able to embark on the total or maybe interacting with all the students, you pick some portion, just 200 from the entire population of, let's say, 4,000. You take 200 and then you use the 200 to, stand in for, let's say, the population. So that 200, whatever you compute within it is called what is the statistic without the S. Okay, please, is it okay?
Yes, please. It's okay.
So that is that. All right. Please, any other question? Okay. So if there is no question, then let's just look at the software side, some basic thing about the software. Then we can now start with the whole thing. These are just an information that I just want to give it to you. But the main thing is more practical. We are not going to do much of the theory, which I believe that is what you are looking for. All right. So the software is, as I said earlier on, it is based on the concept of statistics that programmers have been able to put together to get what is called the software. So we have the full meaning is a statistical package for social, some will say sciences or scientists. They are all okay. And I even learned there is a new name. They have changed the new name. They've given it a new name, which I am yet to get it. So it's a social software, which, why is it social? It's because of the caliber of persons that uses the software for their analysis. Okay, but that doesn't mean that if you are in a technical area, you can't use it. You can use it, but it will depend on maybe what your supervisor wants or what you want to do with the software. It has its own limitations. It's as compared to any other software. There are certain things that it might not be able to do it for you, but it can also do other things, basic things that you need. All right. Okay. So getting to know the software and then how it looks like. So if you take a typical SPSS out, let's say software, and then you launch it, that is, if you open it, you see something like this. Okay, you see something like VAR, then you see 1, 2, 3, 1, 2, 3, and so on over there, right? So someone will ask, what is the VAR and so on? What is it? So they are just the variable. So let's say variable 1, variable 2, variable 3, variable 4, variable 5, variable 6, and so on. Okay. So it is not anything like just the variable name. So if you see something like this VAR, the second one can represent, let's say, age, right? And then let's say the next one can represent, let's say, gender. All right. Now, what is the one that you see here? This particular one here. Then these two that you see over here. Then the 5 also. What is it? They are representing, let's say, your respondent. So someone who went to the field to gather data on students. How many students were part of the study or formed part of for the study? Maybe you took, let's say, 100 students. So then the 100 students, the one that you see represents student 1. Then the 2 represent what? Student 2, 3, 4, 5, 6, and so on. So basically, they are just representing the individuals. So putting all this together, vein 1, vein 2, vein 3, and so on together, at the end of the day, you have what is called a record. So the entire row for 1. Okay, the entire row. Okay, for 1, this one that you see over here. This one, if you put all this in together, it represents what? A record. So that is a record for 1 person. The same way applies to this side, record for the second person, and so on. So if you have 1,000 students forming part, you are going to have 1,000 records. Okay, so let's take note of that. Okay, so once you launch the software, you'll be seeing this. What's the name? This data view, and then that of what? The variable view. Okay, yeah. So you see data view and then the variable view. They are just at the bottom of the application, and it helps you to navigate. The data view is where you enter the responses that you gather from the data or from the field. And then the variable view is where you describe the variables that you have in your study. Okay, so let's take note of that. All right. Okay, so that is it. So a typical example is this. You can see it here. You can see. Okay, so you can see the name, type, with decimal, label, and so on. So this is where the person would describe all the variables. So where you see the name, okay, where you see the name, this side, these are the variables that we are talking. Okay, so these are the variable names. These are the variable names. Okay, so these are the variables names. And then at the end of day, you go to the data view and then enter the responses that you obtained. Okay, you enter the responses from the field. So now you can see it over here. Okay, you can see it over here. Okay, so now you have this is gender. So you can see gender here. Now you can see another variable also here, and so on. Here we've not entered anything. So you can see here there are no records. You don't have anything over here. The person has just, or we have just what? Describe what? The variables. So these are the variables that you see. These are what? The variables that you have in your study. So you are ready to enter what? The data in the data view. Okay, so that is it. So now, once you come here, you can now see some values here. Okay, you can now see some values here. This is 1, this is 0. Now you have 2 over here. So these are the responses that the person obtained from what? The field, right? These are the responses that the person obtained from the field, right? So we will go through all this, at least for you to see how it is. All right. Please, any question with respect to the shots that you obtain from the software? Any question? Any question? Because we need to zoom into the application. Any question so far? Okay, all right. So if there is no question, now please let me launch the software application. Let me launch the software application. Okay, so this is the software SPSS. Okay, I believe you've all launched yours. In fact, my version is version 27. I'm using the version 27. I believe we all have the same version. If you don't have it and you are using the lower version, that is fine. But I believe I sent a link to you with respect to the with respect to how you can download it, right? Okay. Please, have you all launched the application?
Yes.
Okay. All right. So the moment you launch the application, you see it empty. It's empty. There's nothing in it. Okay. So let's take our time. Let's just take some few minutes to go through the menu. So please do yourself some small good, and then let's click on each of the menu. Okay, click on the menu. That is the file menu, and see what is there. Let's try and do that. Click on the file menu and see what is there. Once you are done, please navigate to the edit menu, check what is there, check the view, the data, and so on. Please, let's do that. Let's take our time. Let's take our time and go through the menu. Let's take our time and go through the menu. It will help. It will help. Let's take our time and go through the menu. Okay, please, are we okay? All right, you might not see some of the things because I have installed extra packages on my application. So don't worry, we are not going to use such technical ones, the procedures, right? But later on, I will show you how you can also add more features to your application. Okay, all right, so once you launch the application, you are seeing the variable view and then that of what? The data view. So now this is the data view. You can see var, right? And then there is nothing in it. You can't see anything in it. Okay, everything here, you can see it to be what? Empty. There's nothing here, there's nothing there, and so on. It's empty, right? So now we need to be able to get data into this application so that we will be able to run whatever analysis that we want to perform, okay, on it. But before then, we need to be able to, describe the variables that we have. We need to be able to describe the variables that we have. Okay, so let's just say that we, as part of our data collection or our sample survey or the survey that we did, we have variable like, let's say, gender. Okay, we have variable like what? Gender as part of what? The instrument or the question that you ask. Remember, you are going to use a research instrument like a questionnaire to solicit for your information, or you would use a data that has already been prepared for you, okay, to do your analysis, right? So as part of the data that maybe you have, as part of the data that you have, you want to design the instrument, maybe the variables. So let me share, let's say, a typical questionnaire type with you for you to see what I am talking about. So I'm just sharing a sample questionnaire with you for you to see what I'm talking about. Okay. So, okay. Okay. Okay, so I believe you can see my screen. So you have a typical question like gender. Okay, you have a typical question like gender. And here, gender has two levels. Gender has two what? Levels. So the first one is you being what? A male. And then the second one, you being what? A female. And you are expecting the respondent to select one, a male or what? Female. You need to be able to code these levels that you have. So mostly you can either say that the first level that you have, that is male, should be what? 0. And then the female should be 1. Or you can begin with 1 and then the female will be 2. It means that anyone who selects male, that what is your gender, and you select male, then it means we are going to put there 1. Or if we select female, we must also put 2 there. But it all depends on your coding style. And our advice, if you want to start from 0, please be consistent. Okay, if you want to start with or from, let's say 0, be consistent. Don't start with 0 for male, and then once you come to the age, then you begin to start with, let's say, 1. It is not appropriate. Let your coding be systematic. Okay, so if you are beginning with 1, please know that here will be 1, right? Start with 1 for the males and then 2 for the female. If you get to the next variable, okay, the next variable also begin with what? 1, and then move on in that order. Okay, don't start for a particular one, don't start with 0, and then the next one you are beginning with 1 and so on. It makes the coding quite what? Difficult, right? Though there isn't any format or standard, but from my experience, I've come to realize that the best approach is just begin with a certain number. If it is 1, begin with 1, which is going to apply for all the questions that you have. All the questions. Okay, don't start with 0 for gender, and then you come to question 2. What is your age? Then you begin to start with 5, or let's say 3. It is not appropriate. So if we have something like that, how do we code it? So you just come here, then you can write gen. Either you write gen or you can write it in full, gender. Okay, or you can just write GE. You know what the GE stands for, right? Now, because you are coding, okay, now you want to use a specific name, or let's say a specific level to stand in for it, right? So you need to ask yourself, Jen, okay, now I am coding gender from 1 to, let's say, 2. What type of data type is gender? Okay, so once you click in this button, okay, you click here, okay, you click here, this is the data type, okay, you click here, it will show you the types of data that we have. So here you can see numeric, you can see comma, you can see dots, you can see scientific notation, date, dollar, currency, string, and so on. So ask yourself, what kind of data is gender? Remember, you are coding it from the normal male and female to now 0 and then 1. Okay, so the moment you are coding it from that angle, okay, then it is no more going to be a string, but rather it's going to be numeric. So the best thing is you select what? Numeric. Okay, it means the system should accept what? Numbers, not a string. Okay, a string is like you write the word gender or male or female. It is not, you've not converted it to a number. Okay, so it is very, very important to take note of that. Okay, with the width and then the decimal, I won't speak much. The width is whatever value that you are going to enter there. If it is a text, you need to ask yourself, what is the length, the width of the response that you are going to provide? So mostly it's applicable when you have string data, or you are going to type a very lengthy text in or at the data view, okay? Or maybe you are going to enter a very large number, okay? 1 billion you are writing 1 billion, 10000. Then you need to check what? The width and then even the length of what? The space that you are going to enter it, right? So please take note of that. Okay, now, what is about the label? Okay, what is about the label? Let's take this question here. From the questionnaire, you are talking about what? Gender. Okay, so now the label here is now what? The gender. Okay, the label here is now what? The gender. The label becomes what? Your gender, right? Okay, so you need to be able to just tell the application that I am working with a variable called what? Gender, so that the system would appreciate it more. Okay, please, any question? Do you have any question? Okay, so now I'm going to write gender. That is GEN, stands for gender. If it's about students, so gender of what? Student, right? You type gender of student. In fact, one thing that you must know is the label. Information about the label is what is going to show once you produce what? The table. So if you don't produce any label for the variable name, this GEN, you will be seeing GEN as a result on your table. Okay, so the label is quite important, and it also helps anytime you are sharing data set with someone and there is a label, the person knows, okay, GEN is gender, right? Of what? Student. Let's assume that there is nothing here and you send this data to me. How do you want me to understand what GEN is? I will not understand it. Okay, I will not what? Understand it. So it is appropriate for you to give a label, right, to your variable name, the name that you have created. Okay, the name that you have created, it is appropriate to give it a name, right, or a label. So you have gender here, try as much as possible and then give it a label so that someone would appreciate it. Okay, so that is with the label. So here becomes gender of, let's say, students. If they are workers or whatever, you can add that information over there. Okay, so the next option here is the values. Now we are saying that gender has 2 levels. Gender has 2 levels, right? So we have male and female, and then we have male, you have, this is the first one, that is the male, and then the second one is what? The female. And we are coding the male to be 1, and then that of the female to be 2. So this is where we do that. So you click in this small button here, you click here. Now, the moment you click, you see this, you see value, okay, you see value, and then this one, this is what you see here. You can see this one here, right? The value and then that of what? The label, right? So the value and then that of what? The label. So here you put 1 to stand for label should be what? Male. Okay. Now, once you do that, you click on add. Then you go to next 2, and then what is 2? Female. Then you click on add. So basically, this is how the coding will be done for all the variables that you have, and then their respective what? Levels. So at the end, you get something like that. Okay, we have the missing, maybe if you have a missing response, definitely some will not respond to the question, or maybe some of the questions that you have on the questionnaire. So you can create a room for missing, and you can do it here. You can do it here, or you can do it here also, right? So if you think some people will not respond to the question on the paper, especially, you see, when you ask someone, how much do you earn? You see, a typical Ghanaian employee will not like to disclose that. Okay, so maybe respondent number 1 will give you, oh, I earn 1,000. Another person 400. Another person will not put anything there. Okay, so you can assume that, okay, anyone who do not respond to this variable that I have, I'm going to code it to be 3. So then I can say no response. Okay, no response, then you add. Okay, so gender 2, if someone do not provide a response to, let's say, what is your gender? Male, female, select 1, and the person did not select, then you can also create no response for. So at the end of the day, you can report on those that said they are male, female, and then those that do not even like to disclose their gender to no response will also be there. Okay, so that is that. You can, as I said, you can do it at the missing here. Then any value from here, you say no missing, it means you don't have any missing, right? Now you can put here 3. You can put here 3. If you say your missing is 3, that is fine. The system also respects that, right? But as I said, you can equally do that at the value side. It's the same thing. So there's no need for you to do it here and do it there. All right. So you have the columns. The width of the column is there. And now you have these are alignments. Alignment shows the positioning of the value that we are going to enter for gender. Do you want it to be at the left side? So you have the left, the right, the center. Okay. So let me just enter something here. So if I enter 1, for instance, you see where the 1 is. Okay, where the 1 is. So you can see that it is on the right side. Okay. So now let me change it to center. Let me click center and then see how it will look like. You can see where the value is now, or the response is. If I select, let's say left 2, let's see. Now see where left is. But you see, some of these things, I don't see it to be important, because after what I'm doing with it, whether it is left or it is right. So I don't see anything so important about the arrangement in terms of the left or the right. It doesn't count. It doesn't count. Okay, so now you see the measure, or let's say the measurement that I was talking about. Now, if you click here, you see the three main measurements that I earlier on talked about. So you can see the scale, you can see ordinal, and then you can also see nominal. So as the software has three main measurements. Okay, it has three main measurements. That is the scale, the ordinal, and then that of what? The nominal. Please, any question so far?
Yes, please. Can you go over
All right.
what they mean, the scale, ordinal, and nominal, the meaning?
Okay. All right. Thank you. So the scale comprises of interval and then ratio. Okay. The scale comprises of interval and then that of ratio. And then they are more continuous. They are continuous variables. So if I talk about continuous variable, they are variables like a number, numerical values. So income, for instance, income of employees, the weight, or let's say weight of students. Okay, your weight, your height, the temperature is 20 degrees, 15 degrees, 10 degrees, 0 degrees, and so on. They are all part of what? The scale. Because remember I said the scale comprises of interval and then the ratio, where a typical example for the ratio is, let's say, temperature of the AC, or our environment temperature is a typical example. So if you have a data in that category, okay, you term them as what? A scale. That is when you come to the software, right? You are not going to select ordinal or nominal, okay? Yeah, but see, of late, because of advancement, the software is able to suggest to you that, okay, use this, use based on what you have provided. It should be a scale or it should be a nominal, but please, you need to check it, right? You need to check it. Remember, some of the analysis that are performed, they need to follow a specific measurement. Okay, you cannot perform a typical example like a regression, a normal regression analysis with a string data. The software will not even allow you. It will tell you it doesn't accept string data here, or let's say a nominal kind of for data. Okay, where you have not coded it, it's a raw like that, it will not accept it unless you code it into numbers. Okay, so it is very, very important to take note of the measurement, right? Okay, so that is about the data description. So let me add another one, age. Now, educational level. So when I come here, I just type, let's say, age of students or ages of students, whatever. Then you can also talk about educational level, okay, of, let's say, the student or employees. If you are dealing with employees, fine. If you are dealing with student, let it be known. So you do all this description, and then at the end of the, you go back to the data view. Okay, you go back to the data view. Okay, so this is the data view, right? This is the data view. This is where you are going to enter the responses that you obtain from the field. So you took the questionnaire to one student. What is the gender of that student? what is the educational level of that student, what is the age of that student, and so on, right? Okay. All right. So that is that. So now let's go to the data view. So here, remember we have coded the gender to be 1 and 2. So here, the next person, the same individual, the gender is 1, that is male. His age is, let's say, is 30. The educational level is, let's say, is 1, right? If it is 1, based on the data set that the questionnaire that I demonstrated, right? This is it. It says, what is your educational status? So 1 is certificate, you have diploma, you have a degree, you have a master's, you have a PhD or whatever, right? Then if you have any professional certification, you can add it so that it can be recoded. So this is about it. Okay, once you select number here, the system is expecting you to enter a number. If it is a string, it also expects you to enter what? A string or data. Let me create another one, Gen, and then let's say pick a data type like a string. So a string, I go here, let me enter 1 Gen, so string, I enter, let's say something like, let's say male. I enter male here, right? So here becomes numbers because of the kind of analysis. Here is numeric. So here the next person 2 is 40 years, educational level is 2. Here is also, let's say M, and so on, right? So because it is, what's the name? It is string. It takes, it's alphanumeric, right? It's alphanumeric. It can take numbers. It can take, it can also take what? Normal characters. So please take note of that, depending on the kind of analysis that you want to perform. Okay, so that is about the data side. That is the questionnaire, right? So I believe some of you will be working on a scale data. If I talk about the scale data, let me just show it to you. So a scale data is like this. Okay, this is a typical example of a scale data. So you are conducting your first degree analysis or your master's analysis, or maybe your PhD analysis or whatever, and you gathered or you put these questionnaires together, and you can see it is a scale data because it is taking responses from 1 up to 5. So we ask you the question, what is your view with respect to this question? From 1 up to 5, rate it. Okay, rate it, right? So with that one too, what we normally do is we create what is called a construct. Okay, we create what is called a construct. So someone would ask, it's a construct. So the construct is basically, let's say this, right? Here, the person is looking at knowledge. So you realize that knowledge is the main thing that the person is looking at, right? Knowledge. Now, the second one here is what is called subjective what? Norm, right? So here becomes what? The second construct that the person is looking at. Then the person keeps on asking the question. So you take one construct, you ask question on it. If it is 5 questions you ask, if it's about 10 questions per what literature is telling you, then you need to do that, right? So here too, you also go through the same thing. So you go to your data view, you go to the variable view first. So if you are asking question on knowledge, so you can start with K, let's say K1, let's say K2, K3, K4, and so on, right? Depending on the number of questions that you ask under each word construct. Okay, now, once you are done, you go to this side. Here, you enter the various responses that they gave, right? Their level of agreement with respect to the question. How do you agree to this question? 1 up to 5, rate it. So if you think it is 4, you put 4 there. If you think it is 5, you put 5 there. If you think it is 4, and so on, you put it there, right? So there are different questions per the nature of your research. But at the end of the day, the format is the same. The most important thing is your ability to be able to code. That is all. Irrespective of the nature of the questionnaire that you have, the most important thing is your ability to be able to code and code well. That is all. Okay, please, any questions so far? If you have a question, please kindly bring it on board for us to look at it.
Yeah, hello.
Hello.
Hello. Yeah, please, I have a
Yes,
question.
please. Okay, please go ahead.
Okay, so with the age, what if
All right.
the ages are grouped? As in maybe 10 to 20 years, then we have 30 to 50 years. In that
Okay.
way, when you get to the values, how do you go about it?
Okay, all right. Thank you for your question.
I mean, with the
all right,
coding.
so all right. So it's something like this, right? Something like this, right?
Yes.
What is
Yes.
your
Yes,
age group?
please. Yes,
something
please.
like this. Okay, good. All right. So
Yes.
let me go through go to the variable view. So here, let me create one. Let's say age. Let me name it age group. Okay. There's one thing that I must let you know. When you are writing or giving the variable name, please don't add space. So you can't say age space group, right?
Okay.
You see, you can see here, it says what? Illegal, that is, you have variable name contains what? An illegal character, right? So there should be no space. Okay, all right. So age group, then once you come to the values, right? So here, for instance, you click here, then you type 1. What is the level for
I
1?
can't see the
Let's
screen.
say you can't see the screen.
It says you are doing something, but I cannot see it. If someone can see.
Okay, please, is my screen showing?
Yes, it's showing.
Yes, please.
Yes.
Yeah.
Okay, then please try and check it again. I think others are seeing it. Okay. All right. So you type, what is 1? 1 is from what we have. With a question, we have 20 to 30 years. We have 31 to 40 years, 41 to 50 years. Okay, so this is what we have, right? So once you come here, you type 1 is 20 to 30. So you can just write it like this. You don't need to add the years, but if you want to add the years, that is fine. Then you add, then you go to 2, then you enter 31 to 40 years. If you want to add it, then you add. Then 3, 41 to, let's say, 51. Then you add the years, then add. Okay. So that is all. Okay. So once you get to the data view, you are going to enter just 1, 2, 3, and so on. Remember, you have coded the level from 1 up to 3, right? Okay. I hope it's okay.
Yes, please.
You are okay.
Thank you.
All right. Please,
Yes, please.
you are welcome. Please, any other question? Okay, so there is no question. So does it mean that we will be able to code our own, let's say, questionnaire that we have designed for our first degree research, or let's say our master's or whatever, our PhD? Can we do it on our own?
Another question there. Hello.
Hello.
Okay, so maybe the question is too early, but then I want to know. Does it mean that with SPSS you don't need to export your files to Excel before you use it?
If I'm
Hello, did
getting
you
right,
get
you
me?
said no, please. You can
It's
come
like
again, please.
we type everything. So this is it's like we type everything straight from the questionnaire. So the coding is done straight from the questionnaire. As in, we don't need to export any file to Excel.
Okay. Okay. So what is it mostly, or what I do? Okay. This is how the coding is done, right? But what I do, if I have a questionnaire, is to create a template in Excel. Okay, I create a template in Excel, and then I do my data entering over there, because it's not everyone that is conversant with inputting the data straight into, let's say, the SPSS, right? So you can equally do the coding here. Okay, you can do the coding in Excel. So for instance, the hello, can you hear me?
Yes, please.
Yeah, I can hear you.
Okay, all right. So for instance, this questionnaire that I have, you can see Q1, Q2, Q3, that is question 3, question 4, question 5, and so on, right? So I can't, instead of me to write what is your marital status, I can just try to code them using the question numbers. So I can say, and if you look at this particular questions, you can see it's under section A. So section A, question 1, then you come to, let's say, section B, and so on. So this is what I would do. I can just write section. Let me just, okay, so something like this. I write section A, question 1, right? Or let's say section A1, which I know is section A under question 1, right? Then I do it. If I have 5 questions under section A or 7, I have it like this. Then I create the respondents. So here will be the IDs. Okay, like what you see in the SPSS is the same thing here that I'm creating. So here will be 1, 2, 3, 4, 5. If I have 5, let's say, respondents forming part of my study, this is what I'm going to have. So meaning I have 5 people, and then I have 5 questions to ask. Okay, so the first person what was the response? Maybe it's 1. Then the next variable for the same person is 2, 4, 3, 4, and so on, right? So at the end of the day, you'll be having 1, 2, 3, something like this in your sheet. So this is what is called the coding sheet, right? So you create the coding sheet, and then at the end of the day, you can just copy and then paste in SPSS, or you just export the data from Excel to SPSS. But if you think you can do it straight, you take a typical questionnaire like this. Okay, you take a typical questionnaire like this, and then you will just do direct entering into the SPSS. That is fine. Okay, but mostly I like to do it in Excel and then do some corrections in it. Sometimes I need to filter, need to, do some cleaning and so on. So once you're okay with it, you can just copy the responses that you have or export it straight into or import from SPSS from Excel. So it all depends on you. But I normally, because sometimes I get works and I don't have the time to do the entering myself. Okay, so I have to outsource it to someone to do the entering. So usually I create Excel template for the person, and then at the end of the person will do all the imputation for me. Then I base on that to analyze the data that, or the kind of story that I want to tell, right? Okay, so let me just I want to see if I can, let me show you a typical example of the coding that I'm talking about. Okay, so this is a typical example. Okay, please, can you see it? Is it visible on your screen?
Yes, please.
Yeah.
So yes, so this is a typical coding that was done for this particular questionnaire. This questionnaire that you see, this is someone's master's degree research that we the person contacted us, and then we did the analysis for her. You see, so we create, because the person, let's say the person could not do the data entry and so on. This is a whole work on its own. This is a whole work, because you need to look at the number of variables that you have. Just look at it from up to this side, and you are dealing with, just look at even this almost, this is not the final one, but almost 250 questionnaires. It is not a small task. You get it? So it is not a small, those that understand when it comes to this work, they when you tell them that this questionnaire, someone will enter and take 3 CDs or 5 CDs, the person will be complaining, hey, this small entry that you are going to enter, you are charging me 5 CDs, or let's say 2 CDs or 3 CDs. But you don't know what the person will go through. Sometimes you can spend about 10 minutes on one paper. So if you are spending 10 minutes on one paper, how many days will you use to finish? It is not a small thing. It is not a small thing. So please, these are some of the things, and I'm happy. You are seeing the nature of how this entering is done. Then you appreciate it should you decide to outsource your work to someone to do the imputation for you, and the person is charging you 5 CDs or 3 CDs. I believe you appreciate it. Or yeah. All right. Please, any question? Then we move on. Ask all your questions, so Any question relating to your research data and so on, please bring it on board.
Hello.
Hello.
Yes. Please, with regards to the input of the questionnaires or the data into SPSS,
Okay.
I want to know if you use this new electronic way of data collection and then you want to send it or import it to SPSS. Do you have to go and do coding and other stuff again, or what is it?
Oh, what? Okay. Okay, that is fantastic. All right. So it means you are using let's say a Google form to gather your data. Is that not it?
Yes, please.
Okay. So let me see if I can. All right. So this is let's say a typical one, right? Google form was used to solicit information from the right. Okay. So at the end of the day, you download the data. It will look like this. Definitely, it will look like something like, depending on how you design it in Google form. Okay. Depending on how you coded it, because in Google Forms, you need to code the questions. If you want it to be lengthy, you need to type everything. If you want to use a simple, let's say, words to stand in for the question, you can do that. So at the end of the day, once you download it from the Google Form, you will definitely get something like this. Okay. So by so doing, you are not going to worry yourself with data imputation. It's already done for you. It's already done. Please do get it. It's already done. So you need to now go into the data, right? You need to go into the data and then clean it. As you can see here, there's nothing here. You can see question 7 under respondent number 2 here. The person did not provide any response. So here you can see there is nothing here. So once you get the data in Excel, now you need to ask yourself, what should I do with this kind of empty space that I have? So there's another 1, 2 here. There's another 1, 2 here. What should I do with it? Okay, so you need to apply some basic skills when it comes to data cleaning and manipulation on your data set before you export it to SPSS. Okay, so once you have it in the Google form, there's no need for you to now go and do any input unless you use what? The hard paper. Okay, the paper form, right? So if you are using the paper, then definitely you need to get the data inputted. Other than that, you will not be able to do your analysis, right? Okay. So the data must be inputted first before you are able to export it to the software. Okay. Please, any other question? Are we okay? Okay. I can see. Okay. All right. Okay. So, hello.
Hello.
Hello, sir.
Yeah.
Please go ahead.
So is that the SPSS software questions, and at the same time it's also used for the analysis, right?
Yeah, I didn't get the first part.
I wanted to know if the SPSS software is for coding questions and at the same time for the analysis.
Yes. So at the end of the software will help you to code your data that you have, and then you can now do your analysis in the SPSS. Okay. So let me just open. Let me just open one for you to see. Let me share my screen. Okay, so the question this questionnaire that you see here, this particular one, this is the final data, or let's say the workbook that we use. So now you can see here K1, which stands for gender. And then we have gender 1 and 2. And then what is your age? That one too, you also have it like that and so on, which you can see here. The one that needs to be coded, we've coded all of them, right? Now this is the data, the data view. Now this is the results that we obtain. So at the end of the day, you only be seeing 1, 2, 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? So this is it. So here, I think there were 112 participants in the study, right? So you'll be seeing just 1, 2, 1, 2, 1, 2, 3, 4, 5, and so on, right? But if you want to see what the 1, the 2, the 3, the 5 stand for, so you go to on the screen here, you go to the view. Okay, this side, right? The view, right? You click there and then you see value labels. So once you click on value labels, right? You click on it, then you see what the 1, the 2, the 3 stands for, right? So you see it has changed from 1, 2, 3. Now you can see the real meaning of the 1, the 2, and then the 3, depending on whether you coded it or you did not. Here, we do not assign any coding to it, else you'll be seeing agree, strongly agree, and so on here, right? So that is that. So if you want to see the numbers, you go back again and then you click value labels. It will take you back to the 1, 2, 3, and so on.
Okay,
Please,
thank you.
Is it okay? All right.
Yes.
Okay. So, all right. So once we know how to enter data, code it, I'm also assuming that, I mean, you'll be able to, if you print a paper, or let's say if you are using the questionnaire, you'll be able to do the entering yourself. So let's say those of us going to do our research work and we need to have about 200 people on board. Be prepared to do the entering yourself, right? And I believe it will help you to appreciate some of these things. It's difficult. It is difficult to do that. But if you want to get the skill, then you need to spend time to do some of these things yourself. Okay. All right. So that is that. All right. So having been able to do all this, you see the next action. Before I even come to, please, do you have question with respect to what we indicated earlier? That is from statistics, population, blah, blah, blah. Then data, variable, data view, data entering. Any question? Because we are now going to begin with some basic analysis. Any question before we move to that session? Any question, please?
I want to know how to clean data.
You want to know how to clean data?
Yes, please.
Okay. All right. Thank you for that. It's a very good to ask that question. Okay. Yeah, because when I mentioned that there is empty here, I was expecting someone who say, okay, so what should I do with this empty? All right. Now, there are so many ways that you can use to clean your data, especially if you have some of these things like this missing. They are called missing because the people do not respond to the question. Well, I might not know the reason why they do not respond to the question, but you sent your questionnaire out, and at the end of the day, some of the participants did not respond to, right? So what will you do? What will you do? Are you going to leave it empty as it is, and then you report on it, or you can use another approach to be able to get responses for such, right? So one of the ways that you can do that is you, the researcher. You, the researcher, do you want to leave something empty? Do you want to get an empty space for that particular variable? So gender, you have gender. Do you want to leave it if respondent number 35 do not give his or her gender level? Do you want to leave it empty? It is up to you. Okay, it is up to you to be able to determine it. If you want to comment on those that do not respond to, you can create a no response as I indicated. Okay, you can create a no response for that. So here, the first one is gender. So anyone who do not respond to gender is 3. Remember, we have coded the no response as 3. So you put 3 in here, right? Yes. So that is one of the ways. Another way is more of the statistical side. So we have missing observation analysis approach or techniques, and mostly it is based on the nature of the data. Though we have the categorical side where you can replace, okay, you can replace. But when it comes to the quantitative side, we do more analysis on the data. So for instance, you are taking data income of let's say employees of a given company, or let's say Ghanaians. Remember, some will not respond to that question. How much do you earn? Some will not tell you. Some will tell you, some will not tell you. So what you do is you need to perform statistical analysis on the data set. And then if you realize that the data assumes what is called normality, okay? If the data assumes, or the results that you have
the Gaussian curve
follows, pardon?
The Gaussian curve.
Yes. So once it follows that approach, then you can, at the end of the day, say that, okay, let me replace the mean of the data set with the missing, right? So please take note, we don't just replace. You need to ensure that the data really follows the normal distribution pattern or assumption before you replace with the mean. If the data doesn't look normal, please, it will be appropriate you use the median. The median does not assume what normality. We call something a non-parametric technique or approach. For them, they don't assume normality. Anything it's okay. It can work with limited sample size and so on. It doesn't matter if the sample size is even 5. It can still work with it. Okay, so ensure that your data follows a normal distributing or pattern before you use the mean to stand in for the measurement. So for instance, if here is a continuous, or let's say a variable like income, and some do not respond to it, right? Some are providing 1,000, 2,000, 500, and so on. And others are not also. So let's say, let me just write. Let's say income, you have a variable name called income, and some are saying 2,000, 1,005, I earn 1,005, and another person says 1,000, and another person says let's say 800. Then there's nothing here. Now you move to 5,000, you move to 4,000, and so on. Here you can see there is nothing here. Here is empty. This portion is empty. This portion is empty. This side too is what? Empty. So if you want to replace these missing values or these empty spaces with a value, you need to ensure whether this data looks normal first. If you want to use the mean to stand in for it, you need to ensure that it follows the normal pattern first before you can say that, okay, well, I have to compute the mean, the average of this data set. Okay, I have to compute the average of it. And then at the end of the day, I use it to stand in. So it's like once you assume that the data is normal, then replace the empty space with it. So it's like at the end of the day, the system would replace all the missing with the mean that you have computed, right? And so on. But as I said, let's do it just like that. Okay. So once we take the data set, we will go into it. I mean, I'll demonstrate it for you to see how it works. Okay. Master Solo, please, your hand is up.
Yes. So, please, how can you find out if your data is normal? That is, if the distribution is normal. How can you find out that?
Okay. Okay. All right. So we will use the data set that I forwarded to you to demonstrate. Okay. All right. So let's go to our data. Let's go to our data set. So you can open the data set. You can open. let's try to open the one sample data. Let's open the one sample data that I shared with you. The one sample data I shared with you. So let's open it. So this is what I have. I believe you all have the same thing. Please, are we okay?
Yes, I have it.
Okay, all right. Good. So this is let's say a data set. It's already a prepared one for us. It's a prepared one for us. So we are going to use it to, demonstrate. But I think let me demonstrate how the results will look like. That is the first data that I use. Then I'll come to the sample, the one sample data set. Okay, so here, the first thing that you do when it comes to data analysis, okay, is one, you have to run your basic, if it is a typical questionnaire like this type of, let's say, instrument that we use. The first thing is to run the demographic analysis on the demographic profile, which here is your age, your gender, your educational level, and so on. They might not play a significant role when it comes to the kind of study that you are conducting, or maybe the kind of objective that you are formulating, but it gives an overview as to who are your respondents. When someone picks the result, okay, well, though you are not looking at this, okay, but I can see that the average age of the respondents is, let's say, 35. Oh, then I can see that they are grown-ups, or it is this or that, and so on. So demographic analysis is very, very important. So first, you run your demographic analysis, and then you can also perform your descriptive analysis on the data. Okay, so we have the demographic analysis, which mostly we call it a frequency count, or let's say a frequency analysis on the data. And then once you are done, you run the descriptive analysis. Please, these are very, very important. They are very, very important to take note, because one way or the other, we are writing or we are conducting, let's say, independent research, or maybe writing a thesis, one way or the other. We should take note of that. And I think, let me still show you something small that just for you to get a picture of what I'm talking about. So I'm just sharing the screen. Okay, so this is what I'm talking about. Okay, so you take a typical research that we are conducting in our various schools, whether it's a first degree, HND, master's, or whatever. When it comes to the analysis, you need to break it down. Okay, so we have the initial one to be your demographic, let's say, information. Then after the demographic, so it's like this is the table for the demographic. You have something like this presented nicely, as you can see. You have a nice table that bears your demographic information. And then right after that, you move to your descriptive statistics side. Some combine descriptives and then that of what? Normality analysis. So it all depends, but we will go through each. So now this is the descriptive statistics. Here, the descriptive statistics, you are using the mean, the standard deviation. If you want to talk about the mean, minimum, maximum, and so on, you add them. And then the skewness and then the kurtosis would handle the normality aspect of what? The data set, right? So you realize that you need to follow procedures. You don't just jump and then you'll be doing anything. So for you to get more to write, you need to break your analysis down so that you can get enough to write on. So let me just run something small here on the questionnaire, because as I said, you either be working with already prepared quantitative data or your own data set that you get from the field. So this is a typical data that maybe you can have as part of your research work. that you are conducting in your various school or at your workplace. So how do I do that? Now in the version 27, most of the, or not only the version 27, almost all the various versions, you get most of the statistical techniques, okay, in the analysis procedure or analyze procedure. So once you click on analyze procedure, you see a lot. As I've said, I have installed extra packages onto my app, but you don't have it. For instance, the robust meta-regression, mean, SE, and so on, you don't have it. I know you don't have it. But don't worry, as we move on, I would show you some of them. They are meant to do other analysis, okay? It is not all the packages that they have installed. So maybe our last meeting, hopefully next week, I would show you how you can do that. Okay, now you click or you go to where it's written descriptive statistics, which that one we all have it. So once you click on the descriptive statistics, you will see frequencies and so on. Over here too, I have other packages you don't have, but don't worry. I have other procedures like the normality and then the multivariate normality test. You don't have it, but you have frequency, you have descriptives, you have population and so on with some basic information or procedures in here. Now, the focus is on the frequencies. The focus is on the frequencies. So a typical analysis, if you want to run frequency on your data, you go to descriptive statistics on the menu. I analyze on the menu. You select your descriptive statistics. You select what? Your frequencies. So you click on it, and then here you can see all your items will be here. So all the items that you have defined in the model, or let's say in the data set, you see all of them here. So if you want to run frequency for the demographic profile, right, you select them. Here you can see gender is first, then age, educational level, marital status, and so on. So let's assume that these are the variables that you want to ascertain their respective frequencies count. You just select them and then you move them to this box. Okay, you move them to this session, right? So you move everything here. Okay, you move everything to this box, right? You move everything to this box. So now let me guess, once you select or you highlight, you can see this arrow here. Then you click on it, then it will move the items that you have to the box, right? So after that, you click on this session, okay? You click here. This is
Hello.
statistics. Hello.
Please, I'm lost too.
Oh, please don't get lost. Please, where are you?
I thought we were using the data sets you sent us.
Oh, yes. I'll come back to that. I'll come back to that. Okay. But I'm just using, it's the same thing. Once you get the concept, you can just use any form of data. Okay. This particular one,
We want to follow you do it so that we will really get the skill.
Oh, okay. All right. I'll send you one. Okay. I'll send you one by close of day. Okay, because we have another, let's say, a whole week. Okay. So I'll be sending you exercises. Okay. I'll be sending you exercises for you to try your hands on. Right? Okay. All right. So you click on the statistics, and then these are some of the things that you see. You see the mean, median, mode, sum, standard deviation, variance, range, minimum, maximum, standard error of the mean, skewness, and kurtosis. So the question is this: what do you want? Okay, what do you want? If it's just a frequency that you want, well, then there is no need for you to even click on the statistics. Okay, you just want frequency. It means because if you run frequency on gender and it is 1.5, the mean is 1.5. What does it mean? You realize that doesn't make sense. Does it mean the person is in between male and female or what? Right? So some of the variables, once you run frequency on them, there's no need to add those mean and then standard deviation and so on, because they will not make sense. Okay, so once you do that, you select the demographic profile, then you click on OK. So let me just click on OK. Once you click on OK, your results will be displayed in another view, which is called the output view. So now this is what you see. Right now you can see gender, right? You can see gender, the male, right? They are 25. You can see 25 here. The female too are 87 with their respective what percentage. Okay, with their respective what percentage. Right? Okay. The same applies to the age, right? So those within 45 years to 50 years, the frequency is 5, and then their percentage is what? 4.5. And then those that are between 51 to 60 years, their frequency is 9, and then their percentage is also 8. Okay. Is any question? Do you have any question on it? With respect to the answers that we are getting, do you have
Let's
any
use the
question?
data set you sent us, then go systematically. Please.
Oh, okay. All right. Don't worry. Let me share it now. Can you download it now? Can all of you download it now?
Please, you can share it.
Okay. All right. You let me put it even in the WhatsApp group. Let me put it in the WhatsApp group so that you can even pick it from there. Okay. Let me resave it. Okay. I think. Let me. Okay. All right. Okay. Oh. Oh, I don't know where this data set. Okay. Let me. It's training. Training. Okay, so there's it. All right, so I've shared it with you. You can download it and follow. Okay, so that is so this is the output that you see. Once you run the analysis, you see the frequency, the percentage, the valid, and then the cumulative for percentage. Please, it is not appropriate. It is not appropriate to present this portion. Okay, it is not appropriate. It is not appropriate to present the percentage and then the valid percentage, right? It is not appropriate. At least you should get to this side. You have this. It's enough. Don't add the valid percent and then the cumulative what percent, right? Okay. Now we can, because of the advancement in the software, okay, now they have been able to add a package to it. So let's all try and go through once again. Analyze descriptive statistics, frequency. Now you can see there is something like create APA star table. Okay, create APA star. Sometimes your school or per what you are doing, they say follow the APA format, follow this, follow that, and so on. So they have added it to the application. So you can just click on it. Once you click on it and you say, okay, let's see how the results looks like. So now you can see the APA format as compared to this one that has almost everything. You get it? So let's take note. So this is not the APA format that we are talking about, right? So this is the one that has the limited information with respect to the table. This particular one is what we are talking about. Okay, so this one becomes what? The APA format, right? So this is how your table should be presented. Okay, this is how your table should be presented. Don't bring the valid percentage and then cumulative percentage. It is not, it's like, if you do that, it's like you are not all that professional in one or the other. So just get to the frequency and then the percentage. It's enough. Then at the end of the day, you put all of them together as one table. Okay, something like this. You put all of them together as one table, then you can present it. It is not also appropriate to be presenting table by table. Okay, so it's like if you have 10 of the demographic profile, you'll be having 10 tables. Then at the end of the day, your work will be full of 4 tables. Okay, it is not appropriate to do that. So let's take note of some of these things. It is very, very important. So someone will ask, how do I present my table in this form, this particular form? It's very simple. It is very, very simple. You just copy the output, just copy the, so let me just copy the two, this and that. I just copy. Make sure that you put your hand firm on the control key and then you click to select. So it will select the 2 for you. If you have 3 or 4, just select all of them. So you copy, right click, and then you copy. So I've copied the 2 tables. Then I can go to Excel. Okay, go to Excel and paste. So you are here. You are here in Excel. This is what you have. Okay, try to put them together. Okay, so you can move this one here a bit. Already there is N up there. So you can delete all this session. Then you have this. So here becomes what? Here is gender. This is gender. And then you can move the heading to this side. So at the end of the day, this is what you have. Okay, you have something like this. That is it. Okay. So you have gender, which has 2 levels. The N, the number of people that form part in terms of the male, and then their percentage. Same applies to the age. Same applies to the age and so on, right? The various levels with their corresponding percentage. So you put all of them together, and then at the end of the day, you copy it to Word. That's all. Then begin to do your write-up. You are done. Okay. So as I said, it is not appropriate for you to present table by table. You end up getting a lot. But if you are cool by that, for me, I'm talking from the professional point of view. If you are okay with table by table, that is fine. And your supervisor or wherever you are sending your research work to is okay, that is fine. Okay, yeah. All right, please, any question? The Charles, please, you have a question?
No, please.
Okay, thank you. All right. So that is with the frequency. Okay, that is with the frequency. So now let's go to the descriptive side. Okay, so it's like we are done with the frequency here. We are done with the frequency. Let's go to the descriptive, this session. Okay, this session, let's go to the descriptive side. Okay, so the same data set that I have just shared with you, we are going to use let's say this particular data set, these variables. Okay, let's pick the first 5 and then run descriptive on them. Okay, so we go to the same place, analyze. We go to here, you can go straight to the descriptive procedure. You can see descriptives here, or you can pass through the frequencies. It all depends on you. So for instance, if I want to pass it through frequencies, I select frequencies and then move the demographic profile from the table. Now, I want to focus on the item that I want to perform descriptive statistics on. Now you can see it is difficult for me to see KL1, 2, 3, 4, 5, and so on. So someone will ask, what should I do? I can't see them here. If I see them, it will be easier for me to move them. What you can do is just right click on any, just select any of the items, right? Just select any, right click on any one. You will see display variable names. So just click on it. Now you can see your 1, 2, 3, your Q1, question 2, question 3, and so on, right? So you see them here without the label. So the label is not attached now. It's only the names. Okay, so I want to run descriptive statistics on, let's say, the first 5 items. So I move them in, right? Then I go to statistics, then select, maybe I want the mean, I want the standard deviation, I want the minimum, I want the maximum. So here you can see the mean. This is the mean. You can see the standard deviation also here. You can see the minimum here. They are all here for you. So you select as many as is applicable to you, the one that you can, and what you are going to use them for. Please, my advice is, if you cannot explain a certain statistic or a certain procedure, why do you put it there? Because sometimes you put it in your work. If it is a defense, your supervisors or your professors or your doctors will be querying you and you are unable to answer, which is, it's like, it's a kind of, it worries. Okay, so anytime you put a statistic there, ensure that you understand what it is. Even if someone did it for you, ensure that you understand what that thing is. So that if they ask you, okay, you said mean, what is the meaning of this value that you see? What does it mean? You should be able to explain it to the person. So here we are selecting the mean, standard deviation, minimum, maximum, and then we click on continue. Then we say, okay. So let's say, okay. So at the end of the day, this is what you have. So you have the summary statistics. This is the statistics that you have. You have, this is the mean. You can see the mean here. This is the mean for the first item. The second item has a mean of this. The second item has a mean of this, based on a 5-point scale. So based on a 5-point scale, that is, rate this item from 1 up to 5. So if you agree to this question, 5. If you don't agree, let's say 1. If you strongly agree, 5. If you strongly disagree, let's say 1 or 2, right? Now, we have this mean to be 3.99. Please, can someone explain, if you have a scale of 1 up to 5 and you have a mean of 3.99, what can you say about it? You have given the items or the questions to some people to respond on a 5-point scale. Disagree to agree, where 1 is strongly disagree, 2 is disagree, 3 is neutral, 4 is agree, 5 is strongly agree. And you have a mean of 3.99. Please, what will be your interpretation to that particular question? This one, I think anyone or all of us should talk.
This one is strongly agree.
Okay. Okay, so you go in for strongly agree.
Yes, please.
Okay. Okay. All right. Then who else?
I think agree.
Agree.
Yes.
Okay. Any other suggestion? Okay. So yes. So from what you said, that is great. But remember, it is from 1 up to 5, where we are saying 5 is strongly agree. So if it is not up to 5, we cannot say, let's say, strongly agree. Okay. So here we can once we even approximate 3.99, we are around 4. So we can say that to a large extent they agree rather than to say strongly agree. Okay, so agree will do. Okay, now one thing that you must also take note is when you are writing, you might not have the time to talk about like vital signs of pediatric patients are taking before commencing intravenous fluid therapy. Now you come and talk about agree, disagree, strongly disagree, neutral. You see, it is not, that one too is not appropriate.
Hello.
It is not. Hello.
With this one, this is categorical. Okay. So why do you want to calculate means for these ones?
Okay. This one is not categorical. It is a scale. Because if someone agrees, okay, if someone agrees, let's say strongly agree and agree, there is some impact. Because the person who agree and the person who strongly agree, though they are all agreement, but there is an impact here. If it is just categorical with no special, let's say, impact, like as I said, for instance, gender, male, female, there is no special impact. So here, if you find a mean of 1.5, it will not make sense. I don't know if you get it. Is it clear?
Yeah.
But this one is a scale. And because it's a scale, you want to know the participant, their perception, whether they agree or disagree. So here, if you are doing your write-up, it will be appropriate to state somewhere. I don't know whether you prefer to state it in the methodology aspect of the work, or when you begin writing at the initial, I mean, like under the descriptive, that to make the interpretation easier, you need to classify, because you can't, as I said, you can't talk about all the levels. Strongly disagree, neutral, strongly what agree. So you need to make a statement somewhere that for you to be able to make your interpretation easier, all means from, let's say, less than 2.5 is classified under disagree. And then values above a certain threshold too also stands in for what? Agree. You get it? If you're able to get that kind of, or if you get that stance, it will make the interpretation quite what? Simple. So you need to look at it. What value will classify or will help you to say that you disagree? And what value should you get to classify your result as what? Agree. It is up to you to get a stand. But as I said, you have 1 up to 5. Anything below, let's say, 2.5, mostly I peg mine below 2.5. If you are getting anything less than 2.5, I classify you as what? Disagree. And then if I'm getting above, let's say 3.2, above 3, let's say 3.5 thereabout, I also say what? Agree. But it all depends on you, how you want to do your interpretation. So that at the end of the day, you can make a justification that the people, or let's say the respondents, agreed to or disagreed to your instrument that you sent. Okay. Please, is it okay? Any
okay.
question, please? Okay. All right, so that is good. So all that I need to do is you copy, take it to Excel, and then you format it like how we did it. Create a column for it, something like this. You create a column. So you have the item, then you have the mean, the standard deviation. If you want to add the other ones to it, that is fine. Now, because some of us will be using instrument, that is why I'm taking my time to look at this. You want to check what is called normality. Normality in your data set. Normality in your data set. The responses that are coming out, especially the scale data, and it is performed on a scale data or a continuous data. Don't perform normality on gender. It won't make sense. Or educational level or whatever, right? It will not make sense. But if you have a scale data or a continuous kind of data, it makes sense to talk about normality. Okay, so you want to find out if your data set or your scale data, which is here from K1, 2, 3, and then the other variables, whether they follow what? Normality. You use what is called the skewness and then that of what? The kurtosis to do that. Okay, so we use the skewness and then kurtosis. And studies have shown that skewness and kurtosis above, let's say 2.0. 2.0 suggests that there is a problem of what? Normality. Okay, in other books, skewness should be 2, less or equals to 2, or plus or minus 2. And then kurtosis can take more than 2, sometimes 5, 7, and so on, right? So that is it. Now let me demonstrate. Because I have a special package, I just want you to just see it, right? So let me just run. See, you can see normality or normal test. Okay, so here I just want to just demonstrate something to you, and then I'll come back for you to see what I'm talking about. So let me just select 5 of the items and then run some small analysis on it for you to see. Okay. Okay, this is what I'm talking about. Okay, so here from the software, you can see here, it says that if you can see, it says note, if the skewness is greater than 2 or kurtosis is greater than 7, the data does not form a normal distribution. This one is just 2013. So this one should inform you that when you run the test and your skewness and then the kurtosis is 1 greater than 2 and then 1 greater than 7, then your data does not assume what? Normality. It is very, very important, especially those of us writing our second degree research work, let's say master's, and then that of PhD. The PhD is more, I mean, they want to see some of this vigorous analysis. You need to justify some of these things, whether the instrument that you are even using is good, because some of these assumptions, once you fail to meet, it's like the responses that you'll be getting will not be appropriate, because you want to make a decision, but the responses that are coming out doesn't look normal. Why then will you, or how will you be able to make a better decision on your data set? So please, let's take note of some of these things. You can consult literature on some of these things. In some books, you see it should be greater than, it should be, the skewness is 2, but in some books you see the kurtosis greater than 3. It all depends on the kind of article that you are using to make your reference. It depends on the kind of article that you are using. Here, I can make, if I want to use this one, then I have to acknowledge this particular, let's say, authors, right? So it depends. So if whatever article that you get, it tells you that kurtosis should be greater than 3, you can go ahead, right? So from here, you can see that you have all your skewness values. This is the skewness values. They are all less than 2. Okay, they are all less than 2. And then the kurtosis too, you can also see that they are also less than 7, even less than 2. It's only this one that has 2. So let's say all less than 3. So this implies that your data follows what? The normal distribution assumption. Please, it is very, very important. It is very, very important. Whether you are writing article for publication or a long thesis, you need to go through that. You need to go through that. And if you can see here, we have also done the same thing, that the normality of the data, okay, the normality of the responses, was measured using skewness and kurtosis. So according to her, et al., 2010, the skewness and kurtosis within -2 to 2 suggests what? Normality. This one is according to her. So depending on the kind of reference or maybe author that you are using, her said skewness and kurtosis should be within -2 to 2. Should be normal. So depending on where you are picking your information, you need to acknowledge the person and then you move on. So please, let's take note of that. As I said, for those of us writing a master's degree and we are doing this kind of analysis, let's take note of that. It is very, very important to do some of this. All right, please, any question? Any question?
So if you have one
Please?
condition satisfied and the other is not, assuming the kurtosis is, the skewness is less than 2, but the kurtosis is greater than 7.
Yes, ideally, the normality is all about how your data looks when you have, let's say, a normal curve. So let me just draw one for you to see. Let me just draw a normal distribution curve for one variable. Let me just use just one. Okay. So I draw histogram and then I add the normal curve to it. Okay. So this is it. Okay,
but,
this is it.
But even before that, what number of respondents must you have to be able to draw a normal distribution curve?
What number of respondents?
Yeah, or maybe the data set. I'm asking because let's say someone's work, the person has 50 cases. Another have just 4 or 2.
Okay. All right. So ideally, we are saying that the larger the sample or the larger the respondent, the better the results. Okay. So we have instance where, depending on the kind of technique, we have maybe there will be another session, another training where we will be going more technical, the robust analysis for the higher analysis for decision making. That one, if you are unable to get a higher sample, like more than 200, 300, 400,000 going, the technique will not even allow you to run the test. So normality is good when you have a good data set, but you can still have a limited data and at the end of the day, get your normal graph, like what we see here. This one, the data is just 112, but you still have what? A graph. Okay, but if you want to perform certain kind of analysis, then you need a certain kind of what? Respondent, right? So there isn't no cutoff point, like you should get this before you can perform the normal distribution analysis. But remember, the normal distribution follows certain patterns. One, it takes into consideration the sample size. Yeah, anything that looks normal, it assumes what? Large sample. So we have what is called the parametric tools. They all the time require large number of samples to be used. But that doesn't mean that if you have limited samples like 20, you can't perform such tests. You can perform that. But the idea is they assume that everything is normal. And once it's normal, it's like large observation and so on. Okay. Sedogo, please, have I answered you?
Yeah, it's okay. Thank you.
Okay. All right. So we are looking at the skewness and then the kurtosis of this, let's say, chart that we see. So the kurtosis is looking at the peak of it, the peak. Okay, it's looking at the peak of the chart. You see, of let's say this graph, the peak of it, right? The top, okay, of it. Now, how spread are the data points, okay, to even at the top of it? If it is fairly distributed, okay, it is fairly distributed around, then we don't have what? Problem. But sometimes some here, some there, most of them, or let's say like this one goes to this side, then the next one, it moves like that, and so on and so forth. Then you realize that we have what? A fair what? Distribution. So that is the peak, right? So the skewness is also within the skewness. So is this skewed to the side? See, sometimes you have a data set and you realize that it is centered around this side, or it is centered around this side. This is what we are talking about. So at the end of the day, the two must be fulfilled. It is appropriate for whenever you have normality, the peak, you should see how the data is also around the peak, and then how it is also centering within, okay, this side and then that of for the other side. It is very, very important. But if it is at one side, then you need to do something about the data set. If it is the skewness, why is it that the results that we have, student academic performance, or let's say student marks, you draw a graph, a typical graph, for instance, like this, and it is skewed. What should you do? If you have your way out, can you standardize the data so that those at the low level can at least move to the top? When you do that, at the end of the day, the skewness, and then those who are already at the top, those below would at least catch up with the top so that you can have a fairly distributed what exam score. So these are some of the things that we should take into consideration. But there are certain things that you can't do anything. Once it is skewed, it is skewed. Students will get a score 0. How do you move the student to 5? On paper, it is 0. How are you going to explain the 5 to your authority? that the student has 0, but because I want to have a normal distribution exam score, I move the student to 10 or to 50. And I think that one you will get problem. So with certain is that you realize that you can't do anything about it. But when it comes to some of this, people perception about instrument, about the study, the survey, that one you can do something about it. Okay, so these are some of the ways that you can play alongside and then get a fairly distributed data. But one of the ways is you can find the log of the data so that you can have that fairly distributed data set. Okay, please, any other question?
When I went to the analysis, I couldn't find the normality test.
Pardon?
I couldn't find the normality under the descriptives.
Oh, okay, all right. So, yes, let me share my screen. Okay, it seems because you don't have the package that I have, you wouldn't see it, but we use the skewness. So let's go perform the skewness. So analyze, then we go to descriptive statistics. Even at the frequency, you go to statistics, you select this time around, let's select skewness and kurtosis. So let's select skewness and then kurtosis. So you select skewness and then kurtosis. Then you click on continue. Then you say okay. So now this is what we have. So we have the skewness and then the kurtosis. So this is the skewness. So this is skewness, and now this is the kurtosis. So here you can see that this particular item has a skewness value of negative 0.28, and then a kurtosis value of negative 1.364. And you can see from the results that they are not more than 2. Okay, so either -2 to 2 or -2 plus 2, 2 minus 7 to plus 7, and achieved. Okay. All right. Please, any other question? I think some have dropped because of internet connectivity. Okay. All right. So now let's, Master Solo, please, do you have a question?
No, I'm okay.
Okay. All right. Thank you. Okay, so let's move on to our data, the one sample data. Okay, so let me share my screen. The one sample data. Okay, so what is one sample data, or let's say when we talk about one sample test, what does it mean? So there is, I'll send you a slide on it. Once we are done, there is a slide that's prepared on the technique. Okay, so the one sample is one of the statistical technique. It's one of the statistical technique that enables or that helps you to establish relationship that exists between a predetermined value as against a sample data. So it says that okay, so let me just okay. So you have, let's say you formulate a hypothesis or you make a claim that you have the average age for the student is, let's say, 30. The average age for, let's say, a student on campus is, let's say, 30 years. You make, that is a hypothetical statement that you have made. Now, you need to test this to find out if indeed the average age of a student on campus is 30 years. So what do? You need to go around and then select student or pick student, ask them of their ages. What is your age? What is your age? What is your age? What is your age? Then at the end of the day, you get the data and then you test that data against the predetermined value that, let's say, already researchers are making. So it's like a claim that someone is making. You test that claim against the data set that you have. Okay, you test that claim against that data that you have collected. So basically, that is all about the one sample t-test. Okay, and it assumes one of the assumptions, it follows the normal distribution pattern. So one of the assumption is that it must be normal or normally distributed. It must be normally distributed. The data looks to look toward normal. It must be interval or a ratio data, because you can't perform a t-test winner data like gender and so on. It will not be appropriate for you to do that. Okay, so one of the assumptions is that the data must be one, continuous, which here we are talking about interval or that of what? Ratio. Then it must also follow the normal distribution what? Assumption. It is very, very important. The sample size here should be more. The sample size should be more. But as I said earlier on, even if the sample size is limited, you can still go ahead and perform the test. Okay, so that is that. So I'll send you we are just putting things to shape it more so that you can have a better understanding once you get it. Okay, so with the one sample t-test, we have data on students, let's say score, their reading score, and then that of what? Their mathematics or their maths score. And we want to test this, their exam score against, let's say, a predetermined value. That is maybe over the period, they have realized that the average score that a student gets in reading and then that of mathematics is, let's say, 45. Reading or mathematics is what? 45. So you have to go around, conduct the research, conduct the exams again on students. Then you can compare the predetermined value with the sample values that you obtain on the ground. So you went out there, you asked the first person, maybe the test, what came out? The first person had 63 in English, 41 in mathematics. The second person had 57 in English, 53 in math, and so on. So you gathered it for 20 students. You did the exam for 20 students. And these are their respective exam scores. So we are going to test each variable against the predetermined value of 45. If it deviates, then you can say it deviates. If it deviates in terms of the predetermined value is higher than the sample data, then you can say that, well, the average age score that gated is higher than the scores that the students are getting, or what the students are getting is higher than what we have. In fact, some of these things, it is very, very important. You can, as part of your analysis, let's say your master's analysis, you can bring some of these things in. Maybe you have a variable like gender and then age. If you have literature that says that the average age or the average income of a Ghanaian is this, right? You can compare your own with that, which can give insight, though it might not be an objective per se, but it can give you more information, okay? Because you are writing a long thesis or a long essay, you need to get a lot. And to make your work convincing, or maybe to make your work more interesting, these are some of the things that you can do. You might think it's just demographic, but you can do a lot with it. Once you have literature to support your argument, I think you can do a lot even with your descriptive. Okay, so let's do the test. So how do we do that? So we go to analyze on the menu, then we go to compare means. You go to compare means, analyze on the menu, go to compare means, then you can see one sample t-test. So let's click on one sample t-test. Once you click, this is what you see. Okay, so this is what you see. So these are your variables, and then you have the test values. So you have your variables here. These are your variables. Now, this is the test value. What value are you using as against the sample data? So here we are saying that per our hypothetical statement, we are saying that research have shown that students get on average 45 marks when it comes to reading, and then that of mathematics. So then you put in the 45 here, and then you move the respective variables to the box. Here you have the options to change the confidence interval. But basically, those of us in social science, we are limited to, or we usually focus on 95%. But those dealing with humans, more of chemicals and other products, you can't talk about 95%, meaning you are saying that every 100 people that you get, 5 people can die out of that, which is not appropriate in real life situation. You can't tell us that you should create 5% error. That is, you are coming out with a new drug and, oh, if 5 people die out of 100, it's okay. No, we cannot allow that. So here, because it's people's perception and so on, we can leave it at 95. All right, then we click on OK. So we click on OK, and then let's see the output. So once you run it, you get the statistic, or let's say you get the results, as you can see here. So this is the one sample statistics results. You can see the read, the number of people or participants. The read, you have 20, math, you have 20. This is the mean. This is the mean for reading. This is the mean for math. The standard deviation and then that of for the reading, and then that of the math. Please, descriptively, what can you say about the sample mean and the hypothetical value? What can you say?
The sample means are greater than the hypothetical value.
Okay, yes. So here we can see that the sample mean is greater than the hypothetical value of what? 45. Okay, but you see, we cannot use this one to draw conclusion because this is more descriptive. So if you want to be more of statistical, then we need to move what this side is giving us insight from the descriptive point of view. But as I said, we can't use it to make inferences. Okay, so now, if we really want to say that there is significant difference between the hypothetical and the sample value or the sample mean value, now you need to leave the first table and now leave this one and now come to the next session. Now we are going to work with this particular table. Okay, so here you can see the hypothetical value or the test value to be 45. All right. So now let's look at it. So you have the test, the T value. These are the T statistics. You have your degrees of freedom. You have your significance value. At least this session is even enough. Okay, now, when it comes to statistics, there are so many ways that you can use to make a decision. So some will use the test statistic. The test statistic here is the T. So the test statistic here is the T. That is the test that was performed, the statistical test. So here we are saying that if the test statistic is at least greater than at least 2, then it means there is significance. It means there is significance. Or you come to this session, you come to the significant session and then use the significant value as against the error that you have attributed to the test. So here, because we are testing at 95% confidence level, we have a margin of error somewhere, which is the 5%. So then we are saying that we are comparing the results that we are going to have here with a certain alpha value, an alpha value of 0.05, which is what? 5%. So we are comparing the results with an alpha value of what? 5, which means that if your significant value, okay, if your sig, the significant value, okay, is less than your alpha, okay, your alpha, then we are saying that it shows significance. If what you have here is greater, if it is greater than the 0.05, then we are saying that there is no significance. So from what we see here, you can see that reading has a T value of this, of 4.257, which is greater than 2, and has a significant value of less than 0.05. Here, it is less than 0.001. Okay, so this implies that there is significant difference between the hypothetical value and then the sample value. Now, let's look at the difference. So we have a difference of this, which makes sense, which shows that this 9.85 is quite significant. Okay, so it's like the difference between the hypothetical value and then that of the sample value. The difference is 9.85. That implies that that difference of 9.85 is what? Significant. There are times you perform it and you get a difference, but that difference is not statistically significant. So here you realize that you will not be getting a significant value of 0.05. All right. Any question? Okay, so you have some kind of illustration. Okay, so this same data, so we made the assumption that the mu is equals to 45, or it can be stated that the null hypothesis, this
Hello,
one
sorry.
is that, then the alternative is not equals to 45. Okay. So
Hello, sorry.
yes, sir. Hello, please, I can hear you. Hello. Hello.
Sure, his network.
Hello. Okay. 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 So we have this. Okay. So here it says that the difference means between the population from which the sample is drawn and the population for which the mean reading score is this, right? So this is, if you want to be more of that, then you can just put it in a statement form, and then you move on. All right. You can see the output.
Can you hear me?
What we had. This is the output that you get. The same thing. You have a mean of. Yes, please. If you can hear me. Okay. All right. So, based on this, okay, the material has a lot of information, but let me just based on this session. So it's the T difference. So this portion, this up to this portion. Okay. The confidence interval provides. Oh, what am I?
It's 70 years old, from Bank of the Gold Coast to non-commercial bank, and now JCB Bank. Today, GCB Bank has over 186 branches across the nation. With GCB, our customers are priority.
Okay. Oh, I think I did something and okay, so you oh okay, so here we can see that it says the t-test is used to test whether there is significant difference between the population mean estimated from our sample, which is this, which is the 54.85, and the hypothesis mean to be that. So here it says the p-value is less than the alpha. So as such, we reject the negative. There's a difference in means between population for comes from. Okay, so this is how to interpret the way, but you need to get the tandem. Now, the same applies to the math. The math are the same. It's just that the test statistic is higher. So, and then the significance is same as that. And then the difference to is 7.4 as compared to this, right? So that is something that we should also take note of. So here you can say that the reading, there is difference between the hypothetical statement that they were making, that the average reading score is 45 as against the sample one. The same applies to the math one also. Okay, so that is something that you should be, and then very, very important. The t-test is used when it comes to analysis and so on. So that is about the one sample t-test. Please, any question? I think any question? Okay, all right. So if there is no question, I think let me do one, then we can bring the class to a close. Okay, now there is another one, that is the paired sample t-test, the paired sample t-test, the paired sample t-test. Okay, which is also one of the techniques that is used to measure whether there is difference between two. Okay, but with this one, you use the same individual before and then after. So mostly those in health, they use it a lot. So they will give you, before they bring the intervention, they will assess you. They will take certain vital information from you, your temperature, it's like someone under going through a surgery or so. They will take certain vitals from you. I mean, like your temperature, your pressure, your heartbeat, and whatever. Right? And then after they are done with the operation too, the same individual, they will take certain vitals, whether you have come back to your normal or maybe there's something wrong that they need to maybe find out. Okay, so mostly it's like before and then after. Ideally, we should have even assess your understanding, analysis, SPSS. And then after the training too, we also ask you whether there is an improvement. Has this training helped you? Has it some data set, the training data set. Okay, let's take the training data set paired t-test. All right, so these are
The
some
tests,
tests.
there are two. I think there were three.
Organize, pray, and then post. Yeah, so let's use the first one. The first one. So that is the paired t-test exercise 1. So I will leave the exercise 2 and then the 3 for you to do that within a week, and then we continue, God willing. We start, I mean, like we do the other one on Saturday, God willing. Okay. All right. So, and let's say the first, before you, or maybe the first, before we started the training, I assess your understanding when it comes to statistics, and then data analysis using SPSS. So I asked them, the first is okay, it's called the same individual, test him or her on places. Then he or she scored 48.23. So we want to find out. Hello?
Yeah, Isaac. Hello.
Hello?
Yeah, can you hear me? Hello.
Hello?
Yes, sir. Can you hear me? Hello, Mr.
Yes.
Isaac. Looks like his network.
Yeah, I can hear you. Hello?
Okay. So,
Hello?
yes, hello. Can you hear me now?
Hello?
Can you hear me? Yes, hello. Can you hear me? Hello, Mr. Isaac. Poor network. Is it from my end?
Yeah, I can hear you,
No,
please.
not from your end. I think it's from Mr.
Yes,
Asari's end.
please.
Okay. So I am asking you see the health
Yes.
the health
Yes,
data that you are talking about.
I can hear you.
You know, I can have, let's say, the same patient. Maybe the patient
I
is sick
can
of
hear you.
malaria.
Please, can we hear him?
Yes, I'm talking. Can you hear me? Can you hear me?
Okay.
So I'm saying that
I think his network is going down for him.
yeah. That's sorry. Hello. Hello, Mr. Asari.
Mr. Jacob.
Yes, sir. It looks like your network is bad.
Hello.
Yes, sir, I can hear you. I can hear you. Yes. So I was saying that with the health sector data you were talking about there,
Okay.
the data could come in two forms. One being that, let's say the same individual, maybe the person is sick of malaria. So I am giving the drug to the patient. I want to see whether the drug is capable of curing the malaria. So I will take blood sample before to check for the level of malaria parasites in the blood. And I give the drug to the patient to take. Maybe it's a week course. So maybe 3 days later, I come to take the blood sample to check the malaria parasite again, see whether the drug is working. And then on the last day, which let's say the 7th day, I come and take another sample. That I have done for the same patient.
Yes.
But I can also have this set of data where I have cases and controls. So I have the same patient like I have just described, but I also have another individuals where I have not given the drug to them at all. But then I want to see the behavior of the drug in the ones I have given against the ones I have not given.
Good. So in that case, it is not, you can't use the PED because they are independent. So
okay.
you have what is called the independent t-test.
Okay. So if I wanted to check in between, okay, so the 0 against the 3 against the 7 for the same individual, then the PED, I'll use the PED.
Yes, the PED is the same individual. Let's say before and then after. Okay, before the intervention. But once it is independent, they are on their own. So it's like we comparing performance of, let's say, Presec students as against Achimota. You see, they are different schools, independent schools.
Okay.
So your control will be different from the ones that maybe you gave the drugs to. They are different entities because one took drug, one just took water.
That's fine.
Aha.
Okay.
Yes.
Thank you.
You are welcome. Okay. Please, any other question? It seems our time. Let me just do this and then, so we want to find out if there is, I don't know, it seems the network, so many people have dropped and could not also join. But I think I'll share the videos, the recordings. Okay, so we have pre and then the post examination. So we go to analyze and then compare means, then we select the paired. This is paired. So we select the paired samples t-test. So here we move the first one in the box and then the second one also in the next variable. Then here you can just click on OK. So once you click on OK, this is what we see. So here you have the basic information about it, how many people were involved. You can see here you have 50-50 here. The number of observation, and then you have the standard deviation and so on. This is the mean 50 against 59. And then this one is the correlation that exists between the two variables. Here it's 0.4, which is quite okay. And it moves on and on. Okay. So this is the paired sample. Okay. Please go ahead.
So So from the same kind of data that I described earlier.
Okay.
So is it possible to run or to report on both the paired and an independent t-test, where the paired I am going to look at the before and after for the same group, and then also come and look at the independent between the two groups. The reason I'm asking that is because let's say if it is a drug, I'm looking at a drug efficiency. So some drugs may behave such that when you give the drug to the patient, maybe within the first 1 day or 2 days, the patient will get some improvement. But as the days go by, I mean, nothing really changes much. So maybe I want to see whether the difference between maybe let's say day 1 and day 3, and the difference between day 3 and day 7, whether there's any significant difference between the two or not. Is it possible to do that?
Oh, yes. But it is part of your objective. It's something that you want to achieve. So once that is one of the ways, then the tools are there. So just use it to, tell your story. So it all depends on what kind of story that you want to tell. So if you want to check before and after, you just use the PET. If you want to also examine the independent ones too, you can go ahead. So it is all depends on your steady focus. Yes. Okay. All right. So here we have the PET results. You have the mean, you have the deviation, you have the errors, then we have the significance value here. So here we can see that it is statistically significant. So there is difference between the before and then the after. But you see, here you can see it to be negative. You can see it to be negative, right? All because we put in the first, I think the first value was the pre. Once we change it, it becomes positive. Okay, because if you look at the demographic, or let's say the initial analysis, you can see here that here is 50, the pre is 50, and then the post. So ideally, we can say that after the intervention, there has been some kind of what, let's say, improvements or so, because they scored higher as compared to before. If it is exams like what we are doing, if you're able to score, let's assume that we are assessing you. If you're able to score higher, then it means your understanding when it comes to this software application and analysis, then it's like it has improved. But if it is smaller, then it means there's like the intervention that is in terms of the training has no merit on you, or it do not improve your maybe what you were looking for. So it is very, very important to take note of that. So here we can say that the post-test result was quite impressive. It means that the people have been able to get the understanding, and now they are using it to do their stuff. So that is with the paired sample t-test. The paired sample t-test. Yeah. Please, any question?
Yes. So with this result, if we look at the paired, if we look at the pre, the mean was 50, and the post, the mean is 59. Is this really significant? This is a 9-point difference between the two.
Yes.
Because if it was scores, for example, 59 and 50, you most likely will be in the same category.
Yes, because from the descriptive point of view, this is more of descriptive. So from the descriptive point of view, you can say, well,
yeah,
you getting 50 and me getting 59 is nothing. But from the statistical point of view, this is from the statistical point of view. This session, Okay, so this session is more statistical, and it is telling you that there is significance. So once it's telling you that there is significance, this is a significant. We can't say that. We can't say so much because it's not only looking at how big or small it is, but even the occurrence. How is it occurring? That is why I'm saying that with a descriptive, it just looks at you and describe. So it's like you see somebody, the person has frowned his face, then you pass your judgment on him that, oh, this person is a bad one, it's a bad person. But the inferential test goes deeper into it. Sometimes it has to sit you down and then ask you so many questions. Oh, then the person can draw a conclusion on you that, oh, the fact that he frowns his face doesn't mean that he's a bad person, but rather he's a very good person. That is the work of the inferential statistic. So from the descriptive,
I am asking this question because I did run some test for my data, and for some figures I had like 180 against maybe 171, 172, and the tool is the test is telling me that it's not significant. But you read someone's paper, the person did a similar work like you, and the person have maybe 175, 178, 179, and the person stated that it was significant.
Yes. That is what I'm talking about, that it depends on the occurrence of the data. So you see here, there are so many things that the inferential test takes into consideration before it passes its judgment as to whether it is significant or it is not. And one of it is it considers this. Now come and consider the next one. Consider this one. Consider the next one. So it's like a pairwise comparison. So someone will even have a difference of, let's say, 10. It will still not show significance because of the pattern. Because of the pattern at which the values are or were occurring. Then you can say it is not that you saying, but the program telling you that it is statistically significant or it is not. But one thing too that I must say is, from the Royal Society of Statistics, they are also telling us not to be too focused on the test statistic. Because sometimes you know that this is not right, but the software also tells you it is that. So you need to blend it, especially when you are doing your write-up. I mean, you are discussing. Okay, you can discuss it from the statistical point of view, but what did you also see that you can also add when it comes to your write-up? I mean, like the result that you get. Please, is it clear?
Yeah, yes.
So we need to take that one also into consideration, not only focusing on what the test results says, but at least we must also use our experience to, especially when we are discussing the results or the analysis. Okay, so that is with the paired sample t-test. I think our time is far gone. We're supposed to end at 6 o'clock and we are almost at 6:25. I don't know if I can spend 5 minutes just to do the last one, then we can end it, or we should continue. I'll give you the slide so that you practice during the week. I don't know which is which. Can you give me small 5 minutes?
Okay, 5 minutes.
Yeah.
Okay, all right, thank you. All right. Okay, thank you. So the paired, the independent sample. So this is the independent. Let me launch my data. Okay. So the independent sample t-test. Okay. So the independent sample t-test, as I said, they are independent and you want to assess whether there is difference. So you are comparing the score from, let's say, Achimota, and then let's say Accra Academy. These are two different schools, or KNUST, and then let's say Central University, taking a particular course. Then you want to compare student performance. You realize that Central University is independent, KNUST is independent, or Legon and then UCC, they are independent. So once you have that kind of data set, then you will be able to use the independent sample t-test to analyze the data. So in this case, we want to look at some people perception as against gender. As I said, gender, you are independent. Male, female, we are independent. A male will not influence a female to change. Neither would a female also influence a man to change. So we are all independent. So from the data set, we want to look at, once you get the material, it will give you more description as to what it's all about. So let me take the independent. So this is the independent. You have a lot of variables in it. So we have the perception. This is a perception treat. Perception treat as against, we are taking a variable like gender. A gender. Okay. Now, this is, I did one analysis for one PhD student in UK, and she said her supervisor wants to check whether there's something called, we call something bias, response bias. And it is one of the key things that most PhD students, they do. They want to find out if the responses that are coming out are not biased. So what usually we do is you have to take sample of the data. If your respondents are 400, you can sample 100 from the data, and then you check their gender as against a variable in the data. If the response that you get is let's say significant, then you can say that the results that are coming out from the responses are showing no bias towards the male or that of the female. It is a key thing that please we must follow. It's very, very important. It's very, very important. So let's do that. So we go to analyze, compare means, and then we go to the independent sample t-test. Okay, so the independent sample t-test, you have to move the variable of interest. So here I am after the perceived treat. Okay, the treatment that we give. Is it in the side of, do we give special treatment to females or males? So we have gender. So this is gender. We have the gender here. So we click on gender, and gender has already been defined. That is 1 and 2, right? That is, you are either male or female. So where 1 stands for the male and then 2 stands for female. Then you click on continue, then you say okay. So then at the end of the day, you can see from the results, that the male, let's say if they are student also, their average score in terms of the perceived treatment is 3.4, and then that of the females, it is 3.74. The standard deviation is also shown here. So from here, descriptively, you can say that, well, the females are having higher scores. So meaning we have a special treatment for females as compared to males. But let's see it from the statistical point of view. What is the test telling us? Now it is telling us this. Let's look at it from this point. Okay, so now from this point, let's look at the F statistic. This is the F statistic. This is the significant value. Okay, all right. So here is talking about equality of variance. Do they assume equal variance? This side is for that. Now let's look at whether indeed there is a kind of significant what difference between
Where the equality of variance means, is it normal distribution?
No, please. It is like how the responses that are coming from from both sides, male and female, in terms of the perceived treatment, how they vary. Yeah, variation, like let's say the variance.
So at what threshold do we accept?
Okay, so you are still looking at it from the significant value and then the F statistic. So here, as I said, if it is either 2, more than 2, you are talking about significance. Or you come to the significant side and look at it. Is it less than 0.05 or it is more? Here tells you that it is greater than 0.05. So it means they assume equal variance. So if you can see here, there is equal variance assume. So they all assume equal variation. Please, is it okay?
Okay.
Good. All right. And then we have test of the t-test for the means. So we have for the means. So this is where we want to find out if there is significant difference. So now your variables can assume equal variance, but they might have difference in terms of their means. Okay, so from the statistical point of view, they all assume equal variance. They assume equal variance. And here too, we can see that the t statistic is more than 2. And then the significant value is 0.001. So this one tells you that difference that you see up there, the difference of, where is it? The difference of this is 3.41 as against 3.7. The difference that you see over there is statistically significant. The difference that you see is statistically different. So it tells you that there is the way we treat the female. Okay, the way we treat the female is quite different from that of the men. Yeah, so that is what this result is all about. Yeah. So please, any question? So there is significant difference in terms of the treatment that we give to male and then that of the female. The females are receiving more because if you check the mean, meaning they have a higher score as compared to their male counterpart. Yeah. Okay. Please,
Please,
okay.
Yeah, this part, the 11th test, I think that part, I don't seem to get it right. Because since the p-value is greater than 0.5, then I am thinking that equal variance is not assumed.
Okay. All right. So because the p-value is greater than 0. You see, ideally, how do we state the hypothesis? Equal, the moment is less, then you are rejecting the null hypothesis that there is significance. Please, is it okay? If it is less, then you are talking about significance.
Yes.
But if it is
significant difference, where the null hypothesis, there's no difference, so you reject the null hypothesis.
Perfect. So here you can see that the significance is higher. So it's like you are still with the now. That says that there is no difference.
Oh, okay.
That's
Oh,
the
okay.
variance. The variance that the two levels are having is the same in terms of the treatment.
Okay.
Yes.
Okay.
Okay. Yeah. So, okay. All right. So this is what I was talking about. A lady in the UK doing her PhD, and you see, this is what I was talking about. We call non-response bias measurement. Non-response bias measurement. And this is one of the ways to do it. Okay, you need to perform the test. Okay, so we perform here, even use the t-test to perform it. So please, it is a very powerful tool. If you know how to use it, you will be able to write a very cool story. And that is what we use to say that there is no difference in terms of the responses that are coming. The questionnaire that she took out there, because these are the questionnaire numbers. There are a lot of them. You get it. And we need to check it against what the male and then that of what the females. You need to do that and find out each question. Is there any significant difference for male and then female and so on? How did they answer it and so on? Okay, so at the end of the day, you are able to fulfill. There's an assumption that you need to test when it comes to writing this long thesis that you need to fulfill. That is non-response bias measurement or non-response bias measurement. It is very, very important, especially those using a questionnaire, social science, gathering data here and there to be able to tell a story about something. It is very, very important to do that. All right. I think my 5 minutes is far gone. So I'll share the slide with you, and then you can take your time and go through within the week. Then we'll continue, God willing, next week at the same time. Please, any question before we end the class? Okay. All right. Okay. So since there's no question, then we can end here, and God willing, next week we continue. But as I said, I'll send you the material, the PowerPoint. At least you go through and then you practice, so that you can gather more questions when we meet, God willing, Saturday. Okay. So then.
Thank you.
All right. Okay. Then.
Right, thank you.
Bye for now. All right.
Bye.
Right.
Okay. Bye. God bless you.
Yes.
Thank you too.
All right. Bye.
Very success debate. Breakfast, very passionate one. I was supposed to relax to go on holiday. The point where the police came and got involved. So we'll make it so much more experience. Wow. Big time. The parents don't have one voice. Yeah. Okay. I was born in 1984, which makes you not 84. But that's beautiful. But I know my sister's age. I know my sister's age. I'm gonna say it's Karen. Right? Yeah, right. Randomly you can put the age out there. I thought my mouth was always good. That has 1 point. Karen also has 1 point. All right, let's pass that on. Okay, so I know there are 2 students who come into these, so I really both on, otherwise we'll see. Okay. This is the Jesus. Okay, so this person used to eat chalk when they were younger. They are famous. Okay, they once run away to land. This is the child. So I saw someone walked in also top 10 in her law class. They can only be developed. That's so bored. That's the reason I like the taste of talk. I like the taste of powder. Yeah, you like it though. I know it. So my talk, listen, just like the way my teacher was thinking, like after they would leave the class,